Look around you. Everything that you can see, touch, taste, and interact with in this world is made of either energy or matter. In this section, we will learn about the classifications and properties of matter that will help you appreciate the processes happening all around you. Recall that matter is anything that occupies space and has mass. Matter can either be classified as pure substances or mixtures. Pure substances are further classified as elements and compounds. Mixtures, on the other hand, can be homogeneous or heterogeneous. Pure substances have the same composition wherever they are found, and they cannot be separated by physical means. There are two types of pure substances: elements and compounds. Elements are composed of one type of atom. For example, Coke cans are made up of the element aluminum and are composed entirely of aluminum atoms. All the elements that make up everything are found on the periodic table. Compounds consist of a chemical composition of two or more elements. An example of a compound is sodium chloride, commonly known as table salt. Sodium chloride always has the same composition, 1 part sodium and 1 part chlorine, chemically combined. You cannot separate sodium and chlorine in sodium chloride by physical means such as filtration. You need electrolysis, a chemical process, to separate them. Mixtures, however, are a physical combination of two or more substances. The key distinction between mixtures and compounds is that mixtures are physically combined while compounds are chemically combined. An example of a mixture is sugar solution, a mixture of water, a compound, and sugar, another compound. Since these are physically mixed, they can be separated by physical means such as evaporation of water to recover the sugar. The mixtures can be homogeneous or heterogeneous. In homogeneous mixtures, the components have the same proportions throughout. It's really hard to even tell that substances are mixed. In our previous example of sugar solution, you cannot tell the distinct sugar molecules apart from the water. For homogeneous mixtures, remember that the prefix homo means same. The prefix hetero means different. In a heterogeneous mixture, you can easily see the different parts in a mixture. For example, when you eat a salad, the different substances that make up the salad are clearly visible. In addition to classifying matter as pure substances and mixtures, we can identify matter by its properties. Matter exists in three physical states: solids, liquids, and gases. The different characteristics of matter give us a better understanding of matter. As we go through these properties, I recommend that you obtain a solid and a liquid, and you can use the air around you for the gas. The solid that you are holding has a definite shape and volume. On a molecular level, the molecules are very close to each other with very strong forces holding them in fixed places. The motion of the molecules is very slow. The liquid has intermediate characteristics. While the molecules can move further apart, allowing a liquid to take the shape of any container, it still retains a specific volume, and the intermolecular forces are still strong. As heat is applied to the liquid molecules, they gain enough energy to form a gas. The gas molecules move even further apart in very fast random motions. The attractions between individual molecules become negligible, and a gas has an indefinite shape and volume. Additional characteristics of matter involve physical and chemical properties. Physical properties are those that can be measured without changing the composition of a substance. For example, when you determine the boiling point of water, you do not change the composition or identity of water. Before and after it boils, it is still composed of 2 parts hydrogen and 1 part oxygen. The process of boiling, where one or more properties of matter change, but the identity or composition remains the same, is an example of a physical change. To determine if a process is a physical change, ask yourself this question: did the composition of the substance change in the process? If the answer is no, then the process is a physical change. If the composition changes, however, then the process is a chemical change. As long as one or more new substances are produced in a process, that process is a chemical change. So here's a question: is the sublimation of dry ice a physical or chemical process? Identify the composition of what you started with and what you end up with. Dry ice is solid carbon dioxide. After sublimation, you form gaseous carbon dioxide. The identity of the substance remains the same, therefore sublimation is a physical process. This table has examples of physical and chemical changes. In all physical changes, the identity of the substance remained the same. For example, when water is boiled, it forms gaseous water. For chemical changes, however, one or more new substances were formed. For example, iron, an element, reacted with oxygen, another element, to form a new substance, iron oxide, which we commonly know as rust. In summary, physical properties can be measured without changing the identity of a substance, whereas chemical properties relate to a substance's ability to form one or more new substances. During a physical change, a physical property of a substance changes, but the composition remains the same, while during a chemical change, a substance's atoms rearrange to give new substances. One of the evidences of a chemical change is the absorption or emission of heat, which results in a change in temperature. Measuring temperature is important in chemistry and in life in general. We need to be able to convert between different units of temperature that are used in different fields. Recall what we learned in Chapter 2. Pause after each question and answer before resuming. What is temperature? Temperature is the degree of heat in an object. As we noted in change of states, it is a measure of the average kinetic energy of the particles in matter. When we heat a solid, the heat makes the molecules move faster and the temperature rises. Now, what instrument do we use to measure temperature? So we use a thermometer. And in science, what unit do we use with temperature? In labs and scientific experiments, temperature is measured in degrees Celsius. And last question, what is the SI unit of temperature? The SI unit is the Kelvin. The 3 temperature scales, the US, the unit in science, and the SI scale are placed side by side. Take a moment to familiarize yourself with 2 or 3 reference points. While you will have equations to convert from one unit to the other, knowing reference points will help you with the final crucial step of problem solving, checking your answer. So any temperature close to 32 degrees Fahrenheit must have a temperature close to 0 degrees Celsius and 273 kelvins. The equation that relates the Fahrenheit with the Celsius scale is shown here. You need to know how to use this equation when given either a temperature in Fahrenheit or in Celsius. Note that only the first equation will be provided, so you need the math skill from Chapter 1 to solve for Celsius temperature. Review chapter 1.4 if you need a refresher. The Kelvin scale is a scale that you will learn to love because we will use it extensively when we learn about the properties of gases. To obtain temperature in kelvins, you just need to add 273. Here are some examples of temperature presented in all three scales. For practice, block 2 of the columns and calculate them using the 2 equations that we just discussed. By the time you are done with this practice, you will be a pro. So we have learned that matter can be classified as pure substances or mixtures. The 2 types of pure substances are elements and compounds. Mixtures can be homogeneous, which means uniform, or heterogeneous. We can also classify matter by its states, which are solid, liquid, and gas. By changing heat, you can transform one state to another. Matter can be described by its physical and chemical properties and undergoes physical and chemical changes. Most changes involve a change of temperature that we can measure in degrees Fahrenheit, degrees Celsius, or kelvins. Now, if you have any questions, please feel free to send me an email or ask me in class. Happy studying!